I'm really excited to be here and have this cool group of people discuss about modern application development. So from left to right, I have Tomislav Kar, CEO of Productive, and co-founder of Infinum. I have Dzevlan, DevOps lead with TNTech, who came over from Bosnia for our conference. Thanks, Jenan, for making the trip.
Thank you.
And we have Darko Mesaroš, specialist solution architect at AWS, who came over from Berlin. Thanks for making it, Darko. So I'm going to start with Tomislav, and the first question is for you, Tomislav. And you have more than 15 years of experience as a leader and as an entrepreneur for growing companies. Maybe you want to share with us your experience regarding the development journey of the organizations that you have led. And we're interested in your experience from a leadership perspective. So how you have used different development organizations to drive your companies, what you have learned out of that.
Yep. Okay. So I mean, yeah, I've been doing this for a while, 15 years, and I mean, a lot has changed in the time. And it's, I mean, a lot of it is about technology, but more about is the general industry that just became more mature. Everything became bigger. Companies became bigger. Projects became bigger. You have what was once a team of like 3 or 4 people yelling at each other across the room. Became like a distributed team of 100, 200, whatever people. And it's just completely changed how basically that works. In terms of like just software in general or like stuff like AWS, for us, I mean, I remember, a while ago, I mean, I think like our first server was like a computer under the bed of my co-founder. That's where we hosted our first stuff. It was like an actual physical machine under his bed. And that was 15 years ago. Amen. And then, after a while, we started doing stuff on like bare metal, just, provisioning these machines. Then we did virtualization on these machines, and it was all terrible in the sense that, we were always at this like fear. We had, a couple of outages where the actual machines went haywire. We had this one interesting situation where basically we had like bare metal machines with write disks. You know what write disks are? When they sync data across each other. And, one of these disks went, and then because they sync data, the whole catastrophe of the disk also synced to the other one. So we had to basically, rescue that situation from backups and all this stuff. And why I'm talking about this, and it may seem like ridiculous from today's perspective, is that none of these problems exist today. These are, when you do stuff in the cloud, it's just completely different topics, like this conference is talking about completely different stuff than it would 10 years ago, and approaches and everything. So that's kind of interesting for me, how it changed.
Yeah. And what was the experience of your teams? What's your perspective as a leader because of this change?
I mean, the main experience is that now, people need to think about stuff more in terms of like processes, pipelines. You had jokes before where it was like, "Ooh, never edit code in production," which people used to do, right? Nobody does it today. It's like a ridiculous thing to do. You have processes around that. It kind of enabled us to. So like we deploy the production multiple times a day today.
How many times do you deploy per day?
To production, we deploy at least, I think, about 3, 4, 5 times a day, every day. And everybody, like, we have this rule when the new person comes on to work on the product, they have to deploy in the first day something. It's like, it could be just a typo or something, just to get the whole experience of actually deploying something to production. It's kind of like a good thing, right? Especially if you come like from a legacy system where you had to do like releases that were like, 30, 60 days or something, and then you like deploy on your first day to work. And it might be ridiculous, but it's a good feeling for people, for the team.
Yeah. Great. Thanks, Tom. I'm going to move over to Jenan. And Jenan, you have experience from leading different projects with fast-growing companies. And we're interested in how the cloud in AWS is helping you as a DevOps leader, as a DevOps engineer in fixing different application problems in these environments.
Hello, everyone.
Just move it upwards.
Hello, everyone. Thank you, Yanis. Well, from DevOps perspective, AWS
I think it's really quiet. Is it really quiet? It's better now. Okay.
It's better now.
Okay. Thank you. Well, from from DevOps perspective, AWS made huge improvements for the organizations, how to improve their processes, how to make things easier, like Tomislav mentions, to make releases hourly or on daily basis instead of doing that monthly. Also regarding other things, development workflow process is changed basically thanks to the cloud and thanks to AWS. It's easier to migrate from the on-premise infrastructure to any cloud provider thanks to different services like we have on AWS. For example, for the database migration service will enable you to easily migrate your on-premise database to Aurora or some different database like SQL Server, Postgres, whatever you need. You can easily transform schema to different database vendors, etc. So from my point of view, what else is important is that part of the security. We can now easily include security into our development and operation processes, so security is no more obstacle for us. Now we can easily integrate that into our processes, so when we have releases or different CI/CD pipelines, we can include different security checks to make our platform more secure.
Yeah. It so happens that when you develop applications, sometimes things fail. So how does AWS infrastructure help you manage those development failures that occur?
Well, thanks to different kinds, thanks to CI/CD pipelines and services like code build and code deploy, you can easily see where your code is broken, so developers have an option to easily fix it and then redeploy their changes to development or test environment and make them ready for production.
Can you share with us some stories with companies you've worked, some examples maybe?
Yes, I worked for one client who used a different cloud provider, and he had different issues with performances for their relational database because their workflow was to query, to read from the relational database with a bunch of text, which was not a good fit for the relational database, and then we easily migrated first to Amazon Aurora to use all of the benefits of the Aurora, which is basically database made for the cloud, and after that we integrated DynamoDB as a NoSQL database on AWS, and that works pretty well, and performances are improved, and we were able to migrate from different cloud to AWS in 6 weeks, and that was a pretty two-person works on that project. So
that sounds quick. Any business outcomes for those guys?
Yes, they have their platform in many schools in United States. It's used to improve PhD and master thesis.
Right.
So it uses different machine learning algorithms to improve PhD and master thesis, and everything's running on AWS with great performances.
Great, General. Thanks for the insights. Please welcome Alan Bašić, sitting next to me, project manager with Ingemark, and I'm going to give him the next questions. So Alan, you have quite a strong software development background and also experience in operations and actually running different productive environments. I'm assuming that at some point in your career you've had situations with customers where the development specs for a project were not clear. So maybe you want to share these experiences with us and how running those projects on AWS helps you solve these situations.
Hello, everybody. First of all, sorry being late. I had a topic at the upstairs.
No worries.
Yeah. Okay. Thank you for the question. One small correction. For a number of years now, I'm not in development. I'm a member of our DevOps team. But nevertheless, like a head of DevOps, I'm working very closely with the software and a software developer, and we share same pain. So sometimes I even feel like one of them.
Yeah.
The objectives are changing very rapidly, and this is really something which AWS helps a lot. And there is a lot of services available who helps developers in the project management integration as well, who really allow us to adopt fast and quickly. May I say something? I mean, there is a lot of these
Please
to
go ahead.
enumerate.
We're also interested in your perspective as a leader in using these services, the results you have achieved.
Yeah, I mean, I could stress few of them only. I mean, maybe infrastructure as a code, who can be now hand off to the developers. They can create their own user space in the AWS and execute their task and delete it immediately afterwards. These I like to call them a click-away services, like caching, like messaging, queuing. They are all things which are, I mean, irreplaceable now in modern development. And scalability. I mean, this is something we are all. It's a holy grail for the developer and the DevOps as well.
Why is it a holy grail?
Whatever, scalability.
Yeah.
I mean, you can cover whatever they mess up in the development and put more hardware just temporarily and put it alive for some time.
So solves problems.
And quickly solve the problem, dirty and quickly. But there are some solutions where you have to do and use those values. For the developer, I mean, these new paradigm that are already exist now, it's not only DevOps, now it's DevSecOps.
Okay, can you explain what that means to us?
Yeah, I mean, you have to implement security in every phase of your CI/CD pipeline.
Right.
Especially, you have to force your developer to implement security even when they're coding. So, I mean, if you implement these values properly, I mean that they will have opportunity to change their code regularly, daily basis, deploy without hustle, without stress. I mean, all deployment has to be without stress and should be done. All bit pipeline should produce, from our point and our perspective, a production release. I mean, it has to be properly tested. And then developers are free to change their code without worry to destroy something.
Mm-hmm. Great. Alan, thanks for the insights. I'm going to move on to Darko now. So Darko, we've heard some themes already from the previous speakers regarding what is modern application development. So you're also working with customers in Central Europe and also with many customers also here in the region, by the way. Maybe you want to summarize and give us your perspective on what AWS sees globally as trends in modern application development?
Yeah, so a lot of things my colleagues and friends here mentioned today apply to our vision of what a modern application development cycle or process looks like. So we like to separate it in 5 things. So first of all, microservices, right? Key important thing. Secondly, you have this purpose-built database. So no longer use a single database for everything just because you had Bob install it. You can use the right database for the right job. When you deliver your software, you deliver it every day, right? So there's no longer, you give the guy a disk or a pager guy or somebody else to do the delivery of software. Deliver software, deliver changes through pipelines. One of the other things that we have noticed in the change in modern applications is the operational model. So everybody likes to talk about serverless, right? So we have transitioned to the serverless operational model, right? We saw Alan talk about message queues and notification services. All of those things are serverless, right? So use those things in your operational model so you can reduce the operational overhead. And last but not least, again, rolling back to what people said here, security has to be built in. So security is everybody's job. So developers need to build in security into your own applications. I'm talking to PHP developers here, right? So, and also everybody from development, operations, monitoring, everybody has to understand that security is their job. There's no longer a sec guy. And so I see those things, and this is something I've mentioned in my talk before. Those are kind of the patterns you see in a modern application today.
Great, Darko, thanks for the insights. And I'm going to pick on these one by one so that we can continue. But yeah, in the meantime, Tom,
Just want to
something.
follow up on this because this is an interesting point there, talking about the whole model of actually deploying every day. And I mean, the only way that can work is if you have proper tests. And this is not kind of related to any particular, probably not even like a framework or even like a cloud or whatever. It's just tests. And I remember like a couple of years back, we didn't have like, as an organization, we didn't have testing built in. That was like 6-7 years ago. Right. And we always had developers come up and say, "Oh, we need to start doing more of this testing." Like, yeah, we should do this. Yeah, it's like going to the gym or something. Like, yeah, we should really next week we're gonna start. Like, it's very hard to start doing it if you're not doing it already. But once you get into it, it kind of works. I mean, it's a big effort. It's like there's this big leap that you have to go through to actually learn how to do it. It's a skill by itself. Without it, you can't do CI, you can't do continuous deployment, you can't do any of this stuff. It just doesn't work without like a good testing. And one of the problems that we're seeing today is the testing frameworks and all that stuff works very well for backend code. So if you do whatever, like Ruby, PHP, it's pretty shitty for front-end code. It's getting better, like with Selenium and everything, but if you talk about like continuous deployment on iOS apps or Android apps, it gets harder. It works, there's services to do it, there's ways to do it, it just gets harder. I believe in a couple of years we'll have like proper front-end testing that's not, pain in the ass to do.
Mm-hmm. And who owns the testing in the teams? Who is the owner of?
The way we do it, developers. So we have testing, we have QA, and QA tests it from like more like a user perspective. But developers write the tests themselves. We don't believe, because they know what it's supposed to do, so they need to write the tests to do it. And they need to kind of figure out that their job is not just to deliver the code, but also deliver the tests. Now, obviously, you have to have this like pretty built-in, like, oh, I'm gonna spend like 30% of my time on tests or 20%, like just have this right amount of testing, so it's not too much, it's not too little. And like I said, it's a skill like everything else. It's like it's a good point. It's an art. It's like refactoring or something. Right. You need to know when to do it and not overdo it and not underdo it. People need to work together. One of the things that we also see works very, very well, pull requests in general. That's also a model that showed up in the last couple of years, where people review each other. So I don't think anything goes into production without somebody pull requesting it. Mm-hmm. So somebody has to look at the pull request and just kind of approve it, basically. And the way the model before we did it on a centralized model, so there was one person doing it, the guy that knew the most stuff about the guy, but. Then this is not scalable, obviously. Nothing that's centralized is scalable. So it's just everybody has to pull request each other's code, and it's working well. We're learning every day, of course, how to do it better, but it's working very well.
Yeah, how did you automate all that stuff?
Pull requests.
All that stuff, because you mentioned quite a few things already, like testing and pull requests, and obviously pushing releases to production, right?
Yeah, we run code on a CI, depending on what CI supports, what type of framework. So that's not there are multiple CIs that you can run stuff on. We automate through various testing frameworks where we use them to write code. A lot of problems around testing is data. So when you write tests, they need to typically be around some existing data,
right?
And your application is changing all the time, so your test might work with 2 records in the database, but they don't work with 2 million records. So there's a lot of these different types of tests also. So like you said, it's an art. And I think other automation, pull reviews, pull requests, we do that through GitHub. They have a pretty good system for that, and that's connected all to our deployment. So basically, once we once you push a certain thing to a certain branch, it just goes out to production. That's the way we do it.
I think Jenan wants to comment on that.
Yes, just a quick follow-up on the Tomislav's part where he mentioned tests. And from operation perspective, tests prevents disaster. And also there is a chance to, beside those application testing and front-end tests, to include different security test frameworks so that we can improve global security of our pipeline to do different security checks of our code. And also what Alan mentions before regarding infrastructure as a code. Thanks to infrastructure as a code and services like CloudFormation, finally we have source of truth for our infrastructure. We can easily put everything on the version control systems, and then to do a review of our infrastructure to see who made changes, why those changes are made, and then to deploy everything, hundreds of servers in a few minutes, and to destroy them at the same time, in the same amount of time.
And what's the difference from what we did in the past?
Well, let's say without infrastructure as a code, you had an operation engineers who had to log into the console or to write different kind of the scripts and to perform hundreds of the clicks through the console and do everything manually. And if something is broken, then to fix that manually. Infrastructure as a code give us one benefit, which is called immutable infrastructure. You don't need to SSH on the instance and to do something manually. You can easily isolate that instance and then terminate it and spin up a new in a second, thanks to infrastructure as a code.
There were also we used stuff before that was infrastructure as a code, like Chef Puppet and that kind of stuff, but that was not very good. It was very fragile, and it was basically a robot logging, like something like that. Ansible a little bit better, but it's just changed completely with the whole, it's not actual servers, and just tear them down, bring up new ones. It works.
Yeah.
So that kind of changed, I think.
Yeah.
I'm sorry, I will take a few more seconds. I really enjoy to talk with
Please
all
go ahead.
those people, so we'll probably finish on the coffee after this to continue our talk. But regarding Chef and Puppet tools, you have an agent there, and you need to have it deployed on other servers, and to enable that agent to communicate with other infrastructure, Ansible get rid of those agents, but using CloudFormation and infrastructure as a code, you can easily from your terminal, from your machine, to deploy changes on your infrastructure.
I don't know the details, I just know it never worked. We always did it, it just never worked really well.
There's always...
This works, so I agree this is better. Chef Puppet.
There are always issues with
the idea
permissions and stuff.
Okay.
Like that.
It's interesting perspective.
One of the added benefits of infrastructure as code is you have a versionable and repeatable set of infrastructure. You treat your servers, your network, your databases as a piece of code. So you can apply the same testing and pipeline logic, not just to deploying software changes, but also to infrastructure changes. So I think that's also one of the hidden features of that. And one of the things I do like about CloudFormation and Terraform and Troposphere and CDK and whatever you would like, it's self-writing documentation. So you describe your infrastructure and you just look at it and, wow, it's all documented. I don't have to have a guy do it for me. So,
Yeah.
I think that you can also do like
Peer reviews, like pull requests on that stuff. You can't do that when there was a guy SSHing into a server, because somebody had to be behind him and like, no, don't do this.
That's very cool stuff, guys. So automated releases matter, and I'm going to move on to Alan for the next question. So we heard from Darko about microservices, and we hear that a lot. And actually, we've heard this theme quite a lot in these 2 days in the conference. So why microservices matter for development?
First of all, let me compare a little bit. Traditional, I don't know, has anybody already talk about it, and are you guys all familiar with the technology? But nevertheless, let me compare traditional monolithic application and new modern paradigm of software design called microservice. I mean, okay, imagine SharePoint service. I believe that this is good. I saw your Windows tattoo there. So, yeah. I had to pull something from there. So imagine, I mean, SharePoint is a great service. Don't worry. But there are some strange part in that code, especially if you have huge environment,
Right.
100,000 of users, and every one of them wants to store their documents on the same place, which is basically the function of the code of the service. But then there is an inside feature where you want to produce PDF from any kind of input. Is that working this way, right? You put the Word document or Excel document or a LaTeX document, and he produces PDF. And this is something which is resource. It needs a lot of resources, especially if you're dealing in parallel with 100 of customers. And to scale that service, it's pretty complicated. You need to horizontally scale it. Add more CPU, add more memory, add more whatever.
So that's an example of a monolithic service.
Exactly. And compare that to the solution where you have only that simple task, building a PDF document, isolated in a specific server or specific container. And in order to increase throughput of whole system, add maybe higher container with better resources, more CPU or more, or scale it, add more processes and put a load balancer in front, just for that service. And all other parts can stay the same. I mean, it would be great, right? So maybe this is best way how to compare monolithic. It's a large code, a lot of code, lot of lines of code, all usually deployed in one application server versus 100 of small features, isolated, self-sustainable, who are communicating with each other via API or messaging.
But isn't it complicated to maintain all these hundreds of services?
Oh, this is third time I'm mentioning this technology. It is complicated and it's quite task and challenge, but we have some tools who can help us, especially orchestration tool for let's say containers. If you run your microservices in the container, then you have already available tool like a Kubernetes, like a ECS, who can do this for you, do this heavy lifting, and let you only design and take care of your code. It is hassle and problem if you are doing this by yourself, but if you're using tools, right tools who are available on AWS, then it's not a big deal.
Interesting. So Tom, what's your perspective on all that? We heard a lot about containers, orchestration services, many microservices instead of one monolithic system. What's your take?
I mean, I think all of that stuff is great. Orchestration, containers, I think that's like a given. It's not even like everybody knows that it's great. What I think is the biggest problem is just how to do it, actually. And it's always tailored to your specific case. Like for us, we recently went through this like big migration where we flipped stuff around, and we're still what we do. I don't think we would call that microservices. We have a lot of different services, and then we have like this one that's like a little bit bigger than the other ones. So it's not really our model is maybe more similar to what Stripe does or Shopify, because we're on Rails, Ruby on Rails, and it's like a technology kind of guides you also. Pretty much the way that you do stuff. Our general opinion is to be very pragmatic about it. So when we see the need to do it, we split our stuff into different services. We're not just going to do it because we think it should be done, because it's like then you have all this overhead of communication between the services, which sometimes
so I guess what's the factor that makes you decide, or so what are the criteria that you have?
I think if it's easy to isolate, if it's like really not that coupled to everything, if it's like logically also should belong in a different place. That's one thing, and just the general overhead of communication. If it's something that needs to be fast, we try to keep it closer inside the thing that it's supposed to talk to. It really depends, and obviously stuff changes across time.
I think Alan wants to comment on that.
Yeah, I mean, if you're thinking about the microservices, maybe one of the reasons why to adopt that technology is if you have multiple teams and you want to give them opportunity to solve some specific challenge using not only Ruby on Rails. Yeah, maybe you have a Java team who can use their own knowledge to solve a specific solution, or maybe you have Angular team who can cover front end even better than Rails can do it. I mean, microservice is really letting you have a different team who can focus on specific problems in the system and solve it with a tool they know the best way. Yeah.
Yeah, I mean, we do it like that, to be honest. We have some stuff most of this is on Rails, and some stuff is like on Node.js or something where we need performance. But we try to keep it a limited set of technology because it's just easier for everybody, because everybody is really good at like these one or two things. It's so much easier to share stuff if we can do it. Obviously, if we need like something else, we'll do it, and it's good that the opportunity is there. But from a training perspective, from people perspective, we do try to keep the set of technologies limited.
So, Janan, what do you see with your customers that work with microservices? What should we have in mind? What should leaders be cautious about? And what are some potential benefits that you see there.
How I look at the microservices architecture, it's like on the Lego boxes, where you are able to, to build your infrastructure from the different boxes and to make it the best possible fit for your organization. Thanks to microservices, we are able to utilize best of the cloud. So what we want from the cloud: fault-tolerant applications, high-availability systems, scalable systems. Thanks to decoupling our infrastructure into microservices infrastructure, we can easily isolate different services. We can isolate different services into different parts and then develop them independent from the rest of the infrastructure. Also, if they experience some kind of issues, we can isolate that issues only to one service, not to whole application.
So it's also for issue resolution.
Yes. So, and also we can easily enable developer teams from the developer perspective to develop a different part of the application isolated from the other parts. When you have a large system and when you want to make some changes, everyone would say to you, don't touch this, we will break everything. But when you have microservice architecture, you can easily deploy, develop.
So I'm going to move on to Darko here. And Darko, maybe you want to also connect microservices with databases, because you mentioned also databases before. So maybe you want to give us your perspective in combination, because we hear about containerizing things, we hear a lot about orchestration, we hear a lot about automating that stuff. But what happens with databases in the context of using all these microservices?
So, again, we have this theory of purpose-built database, right? So, and the same way you would use specific microservices for specific tasks, such as converting PDFs or just reacting to user requests or front ends, whatever, the same way you can approach for databases.
Okay.
So instead of using one big off SQL database that will serve all of your content, you can have, quote unquote, microservices of databases that you use a specific database for a specific tasks. You want to log game scores, use a fast NoSQL database. You want to log transactions, you do a SQL database. You want something more complex, storing documents, you can use DocumentDB, right? The MongoDB alternative, right?
But so how can we manage all these databases? It becomes complicated.
Well, so yeah, of course, a lot of these databases come, at least on AWS, comes as managed services, right? And the ones that are not purely managed services come in the form of RDS, where they're managed and hosted by AWS, from all the commercial databases to open source as well. So I think we take all the heavy lifting away from you, so you can kind of focus on just using the database, because your main focus should not be how to run the database, because running the database in itself does not bring your company value, but using the database does. So try to focus on it.
Jenon mentioned an example from one of his customers before for migrating with Aurora. Maybe you want to give us some more insights about that? It seems it's relative to what Darko is saying now.
Basically, thanks to Aurora and Aurora's performances in the cloud, and how we can easily decouple, how we can easily split reads from writes, and even now have multiple master instances with Aurora, we can highly increase our database performances, which we didn't have chance to have inside classic on-premise.
Why do we need multiple master instances?
Well, for the Aurora, you can set up to have multiple master instances, like primary instances, to be written into it, and then also if you have long-running read queries, you can split it to read only Aurora instance, and then increase performances of your application.
So it's for performance.
Yes, from the performance perspective, but what also Aurora brings to us is how they handle the storage in the background, because elastic block storage used by Aurora is split through the different availability zones, so you have also a bigger availability of your data. It's more durable. And
Tom, maybe you want to share with us how you use different databases in your development environments?
Yeah, I mean, it's always an issue using multiple databases, because you get a lot of stuff from it. Like was mentioned earlier, basically, use the right thing for the right job. The problem is when you want to join this data together. So for us, we're a product that a lot of it is around providing reporting, and one of the things that we do offer is real-time reporting. So what Productive does is basically gives you real-time profitability info. So a person comes in, logs in their time to a project, you get the profitability info, momentarily. So it has to be very quick. There's no like, generate report, wait until every hour or any stuff like that.
How do you do that?
It's very hard. It's basically, we focus all of our data in MySQL in a particular database, and then we use other stuff like just caching data for like Memcache, Redis. We use that for caching.
And these are what kind of databases?
Memcache, Redis is just like a key value store, so you could call it. I mean, it's not even like NoSQL. It's just a key value store. You just dump stuff in, but the thing is, it's very fast. So we use it basically for caching. So you could like either pre-warm the cache, just put stuff in. So people, when they come and get that data, it's already like ready for them. Or just the first person that comes and see it, it's kind of slow for them. Then the other ones are okay. Yeah. So there are different approaches, and we're kind of always changing the way we use cache. So we have some other ideas how to improve it right now, where we would like do different types of writes to the cache, opportunistic or some stuff like that. So we're always looking at how to improve it.
Yeah, it's interesting. Seems like a journey. So, Alan, what's your opinion about that? What's your
complete journey?
I mean, if you look at it in the AWS perspective, I have a strong background in the infrastructure, so I perform a lot of activities for the on-prem data center, and the problem with the database especially is it's not that development is not suggesting these ideas for on-prem as well, but to be able to use these things, you have to have experts in many fields. Storage expert, database experts, rollback procedure, point-in-time restore, which are really, really complicated to implement, especially if you're using maybe one of the most used on-prem databases like a Postgres. I mean, out of the box, you don't have anything, but this is enterprise-grade database. You can put it everywhere.
So that's in the on-premises world.
In the AWS, yeah, we have much easier environment to use. I mean, AWS is managing everything, and it's really on the developer to choose their best way how to preserve the data.
So is it okay if I let AWS manage my database?
If they will take care of my backups and point-in-time restores, yes. Of course, you can protect it. There is encryption for that. Yeah. And you can use encryption if you want to store for all your snapshots or your backups. Yeah. I mean, this is one of the best practices, and if you don't believe, you can even bring your own key management system and keep it even more secure than it is out of the box.
Let's move on to Darko, who maybe wants to comment on databases, and then also you mentioned security before, yeah. So and I think it's relevant to encryption, right?
Absolutely. So I mean, databases again. I said all my stuff, right? I said that it's important to use the right database for the right job. And yes, you should encrypt everything. We give you all the tools available. And Werner had this T-shirt on him, encrypt everything. And he always says...
Who's Werner?
Werner Vogels, our CTO of Amazon. Yeah, I'm sorry. We look alike, right? So he says, dance like nobody's watching, encrypt like everybody is. So you should encrypt everything, absolutely. And that brings us to security, right? In this modern world of everything is exposed to the internet, security is a top priority for us and for everybody else. So getting security in from day one, from the developers themselves to your entire deployment pipeline to actually developing your infrastructure should be a top priority, right?
So how do we decide about security? What's the best way to decide about security?
Decide?
Is it something that we discuss per project? Is it something that we discuss collectively? Is it something that we agree in advance? What's your opinion? What do your customers tell you?
Well, so security is always, the top priority, and the security has to be defined on a global level. Okay. So, and with all the security tooling existing out there, not just from AWS, but even from third-party vendors, there's no shortage of it. Right? So security should be the top priority on it, and you should not try to make compromises on security, especially now that you have so much different ways of securing your stuff. So it goes from the top down. Security can be checked against, it can be audited, it can be enforced. So there's different ways of doing that. So compliance and security is quite
I
important.
think Jenan wants to comment on that, and maybe Jenan, you can share with us also how we can automate security. It sounds a bit complicated.
Yes, I would like just to mention, I read an article a few weeks ago about the medical records from the Serbia. That Röntgen images of the bones and very important health records. They were exposed publicly because they were not saved on the secure way on their on-premise infrastructure. And basically, thanks to AWS and different compliance rules which we have available, we can integrate it easily security into our infrastructure and into our organizations. What is important is to take a look on the security as a service, not like an obstacle in our everyday world.
Yeah, how do you do that?
Well, basically integrating security wherever is possible. We mentioned before how we can integrate different security frameworks on our code build servers. Then when you have your infrastructure as a code, you can easily split, for example, security groups and identity management permissions and policies, and then assign them to different people, so that I know that you are responsible for the security groups, the other is responsible for the IAM policies, etc., etc. And then,
can I be granular about that? How granular can I be about the security?
You can easily split it into smaller pieces. So you first have different services available so that you can accomplish that inside AWS environment. For example, you have a Cloud Trail service which enables you to see all API activities inside your AWS account. Then again, thanks to infrastructure as a code, you can isolate a vulnerability easily, and then if you notice that one of your instances is exploited, you will not go and SSH into that instance and try to install some security updates or patches. You will just terminate that instance. Also, but you need to be aware that at the end of the day that can cause different cost issues, because you will lose money if you terminate your instance on which you have valuable data. So you need to find a proper way how to isolate your resources, how to terminate them and don't affect costs for your company.
So, Alan, how do we find a proper way to do all that without affecting costs?
Yeah, I don't think that there is a magic key for that. I mean, it has to be implemented in the practices of the company. But I would like to stress something very importantly. I've noticed, because I'm working with some other companies as well, we are consulting. A lot of them are still saving parameters and burn in the application. I mean, this is something which must be done in the developer level. It has to be explored, some simple features like a parameter store, security manager, who will rotate, issue a temporary permission password and stuff like that.
If I'm a leader, how can I be sure that my developers are taking care of all that? Maybe Tom wants to describe that for us.
I mean, from a perspective where I'm in, there's no real way for me to actually be sure. I mean, the only thing is, I think what Alan said is very important. So you have to have these practices in place. So, I mean, all what we're talking about here is all technology, and the technology is there, but how do you get people to actually use it? And I mean, ever since the dawn of mankind, and computer security has mostly been exploited through social engineering and just calling somebody up, or your developer gets drunk and loses his laptop and the password is 1 2 3 4 5, that kind of stuff. So there's a lot of just people talking about internally enforcing, having, like, we have a bunch of handbooks inside the company that are just processes of how to do stuff, and you have to invest, as a company, you have to invest time in writing this stuff. So how do we do this stuff? And you have to have people that are like very diligent about it, to a point of like, well, maybe don't. Like, people get annoyed by it. They're like, oh, why do I have to write all that? You have to do it. It's the way that we do stuff here.
So,
it's
agreeing internally and putting some policies in place.
Yes, putting some policies and just having people. It's like basic hygiene. You go into the kitchen and the dishes are in the sink, and if somebody, if people start complaining about it, then nobody's going to do it anymore. So you just have to, please don't send me this password over free text or something. Please, that kind of stuff. And then from perspective, that's what I kind of look at. From a technological perspective, I just have to trust the people that are doing it, that it's going to be fine. I don't plan to ever log into AWS console.
So Jenan wants to comment on that. It seems that it's about policies and also about having the right tools in place.
Having a proper security framework inside the company. But also, I want to mention something which is really funny. If people are not aware how security is important, you can force them to use multi-factor authentication, to use Okta, to use complicated passwords, but you can still find password noted on their desktop. Not in plain text, which is silly. So at the end, everything's on the people. How much are they aware of the security importance?
Cool. We have a few minutes. I think I can go on with these guys until the evening, but probably there are some questions from the audience. Please, we have a question there. Please.
Please take yours so they can answer.
Thank you. Nenad Ajbegovic on Solutions. So you mentioned microservices, database security, but one big topic is communication between them. So what is your experience with it? Are your microservices communicating synchronously, asynchronously? Are you using message buses and so on, SQS?
You're talking about security within the cloud, or what kind of security you mean? From the
I mean just communication between microservices. Yeah.
The thing is that best practice should be always use TLS or use SSL, even when you're communicating.
Yeah, is it synchronous, asynchronous? Are you using message queues, something like that?
It's really
SQS.
I thought the question was about security. Sorry. It depends really. It really depends. If you have some simple service who should perform something, and the output of that microservice could be sent to the. We never mentioned the kinases. I mean, this is like Kafka. Yeah, it should be pushed to some simple topic, and some other application will wait for that message and do something after that. Or it can be pushed via, it can be executed asynchronously in most of the cases, but sometimes you want to write down something and wait for the response. If you're talking with the front end, then you probably need to have synchronous communication. So there is no best practice how to implement. I mean, it depends on the situation.
So, like, most of our stuff is synchronous because most of our stuff does something in response to the user's action, where the user has to see something, right? So we mostly use just synchronous communication and JSON as a transport format.
Just quickly, so there's three ways of microservices communicating: APIs, which is synchronously, message queues and notifications, which is asynchronously, and streams, right? So you can use those three depending on your use case, right? One of the things I really like to stress is because a lot of people use synchronous communication, which means APIs. It's very important how you plan your APIs. So again, coming back to Werner Vogel's, on one of his keynotes in Istanbul, he said, APIs are forever. When you create an API, that API must be respected forever. So no matter what microservices change behind, that API must exist and must fulfill its contract. So that's kind of one of the important things I must say.
Great, thanks a lot.
I mean, what we do is, kudos to Werner. What we do is we kind of monitor the usage of, and if it's not used, then because we've deprecated like an API or something, then we kill it after a while. But it is kind of, I won't say forever, but it is for a long time. Yeah. So on every, I believe it is. Yeah.
You just mentioned pops up message queues and streams. So my question is, when would you rather prefer streams than message queues?
I would say the amount of data and the speed you want to respond to it. I would say that would be the amount. Depending on, like, if you have a massive stream of data and you need to work with it, yeah. So
one of the examples when you would like to use streams is, for example, for advertising platforms, when you have large amounts of data and you want to stream those data into the Hadoop or some other database to do something with your data. So that's one of the examples when you want to use streaming.
So basically logging and analytics.
Yeah.
or processing as well. Microservices can process things individually. So
Yeah, so it's a question for you
Brad guy.
again. In terms of database security and encryption, so AWS has encryption at rest that you can just turn on. How does it affect performance? Do you have like a measure? So it's slower, it's not slower, it's like you do some magical things in the background, so it's not slower.
So I'm not sure of the metrics. Do we publish those kind of metrics for performance? I'm sure that there is some performance impact to an extent, right? But I would say it's negligible, at least at some normal scales. But again, let's be honest. You should encrypt stuff, no matter. Like, of course, if the performance impact is massive, yeah, that's a different story. But I think a minor performance impact, if it exists, can be acknowledged for the sake of securing your data. So, yeah.
Thank you.
Okay. So thank you all for being here. We hope you enjoyed. We should move for the raffle.
Yeah.
Okay,
raffle
so
now.
please join us upstairs for the raffle.
What's the price? Car?
You'll see, it's a surprise.
A Tesla, and
Thank you, everyone.
vacation. Thank you.